morning students. Today we are going to see design of experiments, principles and methodologies for process optimization part 1. So the first part what I am going to cover is what is design of experiments, what are the principles and what are the applications in terms of chemical engineering. So introduction to design of experiments. Design of experiments is a systematic approach to experimentation that allows engineers and scientists to study the effect of multiple variables on a process efficiently. So in the last class, we have seen what is independent variable and dependent variable. So how it correlates. Okay, in independent variable, okay, we have a single variable and we have multiple variable. What is the effect of these variables on the dependent variable? Okay, so that is, let's say the dependent variable is efficiency or yield. Okay, so in that case, in that sense, we are going to do the design of experiments correlating the effects of different variables on the yield. Okay, so that's what we are going to do by using a design of experiments. So design of experiments is a systematic approach to experimentation. So the experimentation, even the number of experimentation which has been required can be categorized, can be reduced by using a design of experiments. That I will tell you when we get into a case study. Okay, now please try to understand design of experiment is a systematic approach to experimentation. Instead of changing one factor at a time, design of experiments enables the study of interaction between the multiple factors. Interaction between the multiple factors. Let's say you have pressure and temperature. Okay, how the pressure or temperature or both will affect the yield. Okay, so and also the interaction between these factors, how it affects the yield. Okay, leading to a optimized process condition, improved quality, and reduced experimental cost. So, what are the key principles of design of experiments? The factorial design, randomization, replication, blocking, or response surface methodology. So, these are the key principles of design of experiments. So, this design principles is not independent. These are 5 principles is not independent. It may be a combination as per the requirement of the problem statement. Okay, for optimization, mostly the factorial design as well as response surface methodology can be adapted. Okay, we will try to see what are these 5 principles, how what does it mean, okay, in this lecture. Factorial design investigates the multiple factors simultaneously to determine their individual and combined effects. So the factorial design investigates multiple factors simultaneously to determine the individual and combined effect. Because of the individual effect, what is happening to the dependent variable? Okay, sorry, independent variable, actually dependent variable I already told you. So let's say you have pressure and temperature. These are independent variable. So the dependent variable is the yield. So when you change this variable like temperature and pressure, what will happen to the dependent variable? That's what this one meaning means. Okay, investigates multiple factors simultaneously to determine the individual and combined effect. Randomization ensures the results are not biased due to external variables. So the results are not biased due to external variables. Randomization, when you think that the external factors of the experimental condition, for example the cooling effect, if the experiment has been conducted in a air conditioning room, okay, so in that case the external factors is the cooling temperature, so it should not affect the either any of the process. For example, the effect of external temperature, okay, in absorption. So what is the effect? So randomization ensures the results are not biased due to the external variables. For example, the noise. When the lecture, when I'm taking a lecture, if there is a noise comes from because of the fan. Okay, so whether this fan will have an effect on the lecture delivery. So I want to remove that thing. So make sure it does not have noise. Okay, ensure that the results are not biased due to the external variables. So we need to apply a randomization. Hope you understood what I am trying to say. Okay, replication. repeating experiments improve statistical reliability. So most of the time when you see the papers which has been accepted, they say the concordant values were taken. So meaning to say is not one variable, is a concordant values has been taken. Because of that, they will study the what is called bar chart. Bar chart in the bar, sorry, in the bar chart they will have a error bar. So the error bar indicates is not conducted in one. It may be having a conducted in triplicates, okay, or more than that. So until we get the concordant value, so that the error bar will indicate is not been carried out in single, the experiment is not carried out. Okay, repeating experiments improves statistical reliability. Blocking reduce variability by grouping similar experimental conditions. So reduce variability by grouping similar experimental conditions. Let's say there won't be any much effect because of this. So the experiments, design of experiments will calculate, will identify the points, okay, reduce the number of experiments. Blocking reduces variability by grouping similar experimental conditions. Reduce variability. Let's say some of the variables which is not been having a much effect on the dependent variable. Okay, so in that condition, reduce variability by grouping a similar experimental condition. So then we need to go for a blocking techniques. Okay, so these 5 experiments principles may be combined together or may not be combined together. Okay, for optimization, mostly the factorial design and response surface methodology will be combined. So you should understand these principles of design of experiments. Response surface methodology used for optimization by modeling responses over a range of conditions. So, yeah, I would like to say the design of experiments has been carried out by me during my or during my PhD. Okay, response surface methodology, two factorial design as well as RSMN was implemented. I will show that one as a case study in the coming class. Okay, in the coming class. Okay. Now, let's say what are the examples for design of experiments? So, for easy to understand. Let's say optimization of reactor condition in a chemical process. So, you know already the reactor is like a heart of the human. Okay, for any chemical process, the reactor is very important because when you convert the raw material into product, anyhow there will be a reactor definitely will be there. So that's why it's a core subject. Reaction engineering is a core subject of chemical engineering. So the optimization of reactor condition is very important because you are optimizing the process as well as the point so that the yield will be more. Okay, the process or point what I mean is this yield. Okay, so determine the optimal condition for maximizing the yield in a batch reactor. Let's assume a batch reactor. Okay, in that I want to know the optimum condition. So for which if I run the batch reactor in optimized condition so that I will get a maximum yield and then with the low energy consumption or low energy needed. Okay, so reaction temperature. Let maybe take low, medium and high. I don't know at what temperature the reaction yield will be more. And catalyst concentration, let's say the reactant concentration or the catalyst concentration. Here they didn't mention the reactant concentration. Here they mentioned the factors which need to be considered is catalyst concentration. 0.5%, 1%, 1.5%, that is the one varying. Okay, whereas the reactant concentration for this case is constant. They are not varying the thing. Okay, so agitation speed, they are varying 100, 200, 300. So this one is not a one factor at a time, is a multiple factor. That means we are varying the independent variable, varying from low, medium and high. Okay, for all these 3 conditions. So even for catalytic concentration, we can consider 0.5 is a low, 1% is middle, and 1.5% is high. Agitation speed. So the factorial design is used to study the effect of temperature, catalyst concentration, and agitation speed on reaction yield. That is a factorial design is used to study the effect of these variables. Interaction effect. So what is the interaction of temperature and catalyst concentration on the yield? That is an interaction effect. Is a, you may say actually is a what you call it, synergetic effect or something. Okay, synergetic effect of independent variables. Okay, response surface methodology is applied to find the optimal condition for the maximum yield. So the outcome is by applying the design of experiments, yeah, optimal reaction temperature of 70 degree, catalyst concentration of 1.2% and agitation speed of 250 is found to be maximum. by using a response surface methodology. Hope you understood what I am trying to say. Okay, so coming to the second example, improving the distillation column efficiency. To optimize the separation efficiency of a distillation column of a binary mixture, what are the factors you could be able to vary? Reflux ratio, feed temperature, number of trays in the column. So that if the what do you call it? The separation efficiency is supposed to be higher for a binary mixture. Let's say imagine. So when the number of trays is higher, that means what does it mean actually? The reflux ratio, as the reflux ratio increases, okay, the number of trays will be shorter. That you know already the correlation. But we have a control of three factors at a time here. Is not only a single factor. By varying these three factors, we need to identify the optimum factor, okay, optimum condition by using the design of experiments. Okay, so a full factorial design is used to evaluate the effect or impact of reflux ratio, feed temperature, and tray number on separation efficiency. So blocking is also added here to eliminate the variability from ambient temperature effect. Let's say you have a distillation column, energy need to be given in a reboiler, okay, as a energy input, so that what will happen because of the vapor pressure uh, difference, okay, the boiling the two components will be separated because of the relative volatility. Relative volatility has been defined as vapor pressure of one component A divided by vapor pressure of component B for a binary distillation. Okay, so for this case, blocking is used to eliminate the variability from ambient temperature effect. Let's say the distillation column has been kept in a uh, what you call that, not at a normal temperature, okay, that is not at a room temperature. Okay, so obviously this may have an effect on the things. So when you supply heat energy, there may be losses of heat because of the ambient condition, because heat may be dissipated unless otherwise it has been what you call them proofread. I mean proofread in the sense what you call the protected. Okay, so it's a insulated. Okay, with the correct word is insulated. Sorry. Okay, so the statistical analysis is conducted to determine the significant factors. So which one is significant? Okay, whether is a single factor or is a combination of A and B. Okay, we have three factors here. Okay, A, B, and C. One is reflux ratio, B is the feed temperature, and C is the tray number. So what is the effect of these variables? Okay, statistical analysis, one-way ANOVA or two-way ANOVA analysis of variance can be calculated, and we will get a statistical analysis as well in the design of experiments. By seeing the design of experiments, we can come out with the conclusion that whether is a which one is more dominant, is whether the variation of these variables having a significant effect or not, that we can determine. Okay, that you know already studied in the statistical analysis in mathematics, right? So DOE helps determine that the reflex ratio is 2.5, feed temperature of 75, and 15 trays provide the best separation efficiency. So when you have this condition, that means we can give you a factor. For example, the reflex ratio is higher. Okay, the reflex ratio, which one is predominant? Okay, which one is just considered is the thing. So when you see the reflex ratio or the number of trays, we can give a scale of range. Okay, when you give a scale of range, based on the scale, it will try to find the optimized point. When you try to do the design of experiments, you will understand. Now just try to understand design of experiments will help you to identify the optimized point. Okay, for this case. Coming to the third case, minimize the waste in polymerization process. So the factors which are need to be considered is monomer concentration, initiator, and reaction time. So you may ask me why you already have multiple variables. So you also can vary only one factor, one variable. Okay, that is a independent variable, and then you can optimize the process. For example, I just say initiator dosage is constant, reaction time is also constant. I just would like to vary the monomer concentration and would like to see the quality. Okay, to minimize the waste generation in the polymerization, okay, process will manufacture the product quality. So whether by changing the monomer concentration, the minimize I could be able to minimize the waste generation if I calculate by keeping the other variables constant. That is a one factor design. Okay, so if it is a multiple factor, so we can go for Taguchi method. Taguchi method is also coming under the design of experiments used to identify the most influential factors affecting the waste generation. Among these three, any one of the factor will be a most significant factor which will have a higher effect on reducing the waste, waste minimization. Okay, we'll have a higher waste minimization. We can use it by Taguchi method. What is replication? Replication ensures the reliability of the results. Response optimization is performed to minimize the waste while maintaining the product consistency. So the outcome is by using the design of experiments, okay, the 40% monomer concentration, 0.4% initiated dosage, and 4 hours of detection time, reducing the waste by 15%. Let's say, if for example, I just have only one significant factor, monomer. The other factors will have a not much significant effect. Let's say even the 40% monomer without changing the initial dosage. I mean, you are just closing to the optimized level without changing the initial dosage at 4 hours of reaction time. If it goes to the reducing waste by 14% or 13%, there is no much significance by having another two factors, right? So that's the thing. So please try to understand the design of experiments. We may not be knowing what may be the interaction between the variables, independent variables, on the dependent variables, or only one variable have a much effect on the dependent variable, that we can study by means of design of experiments, and that is by using a statistical method and things like that. This is embedded. Okay, so the fourth point is optimization of heat exchanger performance to maximize the heat transfer efficiency while minimizing the pressure drop in shell and tube heat exchanger. So I have given a lot of examples in chemical engineering perspective. One is in reaction engineering, one is in waste minimization, now distillation, now is in heat exchanger. So similarly, the flow rate of hot fluid I just varying, the airfill spacing I am varying, need not be necessarily only these factors. For heat and shell and tube heat exchanger, you also can vary the things, different factors, other factors. Okay, the inner diameter of the tube, or the cell type diameter, or the tube side diameter, you can vary and you can find out the optimum condition. So the optimum condition is the maximum heat transfer supposed to occur in a shell and tube heat exchanger. Or you can have a one shell, two tube pass, two shell, four tube pass. That also you can vary. Okay, so the factors which need to be considered here for this thing is a multiple variable. So the factorial design of approach, design of experiments approach is used to evaluate the impact of flow rate, baffle spacing, and the tube diameter on heat exchanger efficiency. Randomization ensures the external environmental effect do not bias. So the bias, in order to avoid the biasing, randomization is make sure that it has been applied. Okay, response surface methodology helps determine the optimal balance between the heat transfer efficiency and the pressure drop. So obviously we want a higher heat transfer efficiency, at the same time we want a less pressure drop. Okay, so the outcome is at this requirement of the output we require, that is a factor, that is a dependent variable. Okay, the heat transfer efficiency is dependent on the previous factors like flow rate, baffle, and tube diameter. This dependent variable, okay, the yield, the dependent variable depends on the independent variable. The independent variables are flow rate, baffle spacing, and tube diameter. So by using the design of experiments, we could be able to optimize the thing, and we found that flow rate is 75 liters per minute, baffle spacing, and tube diameter. In I will also show you the demo for design of experiments. Okay, this is the last one. So I don't want to explain much. You know already by reading out this problem statement over here. Okay, so what is the objective? I mean, by reading out the example over here, and you could know actually what are the factors that they are varying. Okay, so the ultimate what is the output actually? To reduce the defect in tablet production while maintaining the tablet strength. So the factors are compression force, binder concentration, and drying temperature will help you to find the optimum what do you call it? Optimum condition. So what is the optimum? Reducing the defect. So is a logical regression analysis also. In the last class we have seen, yes or no. So this optimal condition has been having the thing. They obviously the product will be with the standard, right? So that's why by seeing this optimum condition we can say whether the binding force, what do you call it? Sorry, yes or no. The logical question can be answered. Logical regression analysis. Okay, so the Taguchi experimental design is used to study how different factors influence tablet defects. Replication ensures accurate results. Blocking applied to account for batch to batch variability. The outcome DOE reveals that using a compression force of 10 kilonewton and binder concentration of 2% and drying temperature of 60 degree reduces the tablet effect. Okay, coming to the conclusion of today's section, Design of experiments plays a crucial role in optimizing the chemical engineering process. So we have seen the different processes, right? Unit operation, like distillation column, what called even reactors, unit processes. Okay, so these are the things actually could be able to optimize. So you, obviously in the chemical engineering thing, we have a unit operation and unit process that you know already. One is physical transformation, both physical and chemical transformation takes place in the reactors. Okay, improving the efficiency and minimizing the cost. So design of experiments is used plays an important role in optimizing the chemical engineering process, improving the efficiency and minimizing the cost. So once you optimize the thing, obviously the cost will come down because the energy consumption will be more, energy consumption will be less and the efficiency will be more. By systematically studying the multiple factors and their interaction, design of experiments enables engineers to make data-driven decisions whether this factor is having an effect on the dependent variable. Okay, so the dependent variable is the output. Okay, so the output is a function. Okay, this function is a factor of something. Hope you understood what I'm trying to say. Okay, with this note, I would like to conclude today's section. We will see the design of experiment second part very shortly. If you have any doubt, please don't please feel free to ping me in the Google Classroom. Then and there you just clarify your doubts and please try to understand the content with chemical engineering perspective. That is very very important because this course code when I try to explain and the subject name when I try to explain data analytics and machine learning for chemical engineers. So all the aspect, even the machine learning algorithm, everything in terms of chemical engineering perspective, let's just look into it and try to implement in that and then try to understand the concept. That is very very important. Okay, so I can give a lot of other examples, but I am very specific on the chemical engineering principles and examples. Okay, hope you understood. I stop it here. We'll see you in next class shortly.